Hi everyone, my name is Shanine Bari, and this is my final project about the BIOL lab at UNC. Okay, I want to start by asking you to imagine a scenario we are all too familiar with from the past few years. You feel terrible. You have a fever, the chills, and you're shaking. You take a rapid at-home COVID test, and it comes back negative. Now, usually, if you test again in the next few days, it comes back positive. But what if it never did? My final project focuses on the Infectious Disease Epidemiology and Ecology Lab, also known as IDEAL, at UNC. This lab studies a wide variety of infectious diseases all around the globe, and today I'll be presenting about their work on diagnostic-resistant malaria. Just like how COVID might not show up positive on a test, malaria parasites in Africa have evolved in a way to become invisible to our standard medical tests. Today I'm going to tell you how the IDEAL lab is hunting down this invisible enemy. To understand this problem, we first need to understand how we test malaria. Malaria is a dangerous disease that is caused by a parasite on a mosquito, and people get it when the mosquito bites them. In Africa, doctors use rapid diagnostic tests, also known as RDTs, to diagnose this. This test is very similar to the COVID test we use at home. Now, the problem with malaria is that it can avoid being detected on these rapid diagnostic tests. To understand how this works, let's imagine an analogy between a security guard and a criminal. The security guard has a very specific set of instructions. If it sees the face of the criminal, he needs to sound the alarm. But if he doesn't see the face of the criminal, he doesn't sound the alarm. In scientific terms, this face is a protein called HRP2 that the malaria parasite produces. If the alarm is sounded, the face, aka the protein, is detected, giving us a positive test. If it is not detected, it is a negative test. The system works great until the criminals learn how to hide or change their face. So, how does malaria trick the security guard? The IDEAL lab studies parasites that have completely deleted the gene responsible for making the HRP2 protein. Imagine the malaria parasite is a person identifiable by a specific tattoo. That tattoo is the only thing the security guard knows to look for. If that person goes and gets the tattoo laser removed, then they are the exact same person, still just as dangerous, but now they can walk right past the security without setting off the alarm. That is what's happening biologically. The parasite is still in the blood, making people sick, but because it deleted its tattoo, aka the HRP2 protein gene, the test reads negative, even though this is a false negative. So, the IDEAL lab found these malaria mutants through a method called the double check. They traveled to the Democratic Republic of the Congo and tested 7,000 children. For every child, they ran 2 tests. They ran a standard rapid test, which we just explained in the security guard analogy, and they also ran a PCR test, which is like a biological copy machine that copies a part of the DNA so scientists can see what part of the gene is really present. They looked for a specific mismatch. They were looking for kids who tested negative on the rapid test, but positive on the PCR test. When they analyzed the DNA of these mismatched cases by running more tests, they confirmed the gene producing the protein that the rapid test was looking for was actually gone. Then they were able to use geographical methods to discover that there were 2 distinct clusters of these mutant parasites spreading in the Democratic Republic of the Congo. This proved that the invisible malaria is real and that it was clustering in specific communities. On this graph on the left, you can see where in the DRC this mutant malaria was most clustered. This task was not easy. The IDEAL lab at UNC collaborated with researchers from the Imperial College of London, the University of Kinshasa, and the DRC Ministry of Health. By combining local knowledge with advanced genetic tools, they are working to update global health policies to ensure that negative really means negative. Thank you to all these researchers for working to keep our world healthy and safe.